Okay, so today we're going to talk to you about Ospf. Now, Ospf, it's a known routing protocol, and I'm going to try and break this down. Okay, so now the question you should ask yourself is: so what is a routing protocol? Okay, so a routing protocol, and I'm going to try and do it. It's a known methodology, a system, particularly, uh, let's reduce it just a bit. A router will route traffic and into brackets, packets, information, status to another router using a language they both can agree upon. So a protocol is purely nothing but a language used for a particular purpose. Okay, so that is a routing protocol. Now, Ospf is one of the most popular ones, and if you want a way to check some job interviews as a network engineer, they will be requiring that you should have a well-versed knowledge of Ospf. Now, today we're going to do a quick config of Ospf. I'm going to just slide this down here somewhere. So what I'm going to do first is I've got router 1 and I've got router 2. So let's say this router 1 is London, and it's connected to a branch office of, and we call the name for a company, Softclap maybe, a branch here in Paris. Okay. Now, the name of the company here is Softclap Technologies, and they decided to use Ospf protocol. So now we know that it's Ospf, I can safely delete this. So Softclap Technologies, you are the network engineer, and they have a branch in Paris and a branch, the main office in London, this HQ, headquarters, and you need to connect the two so they know what is behind this area. And I'm going to put that in a box. Draw a rectangle here. So behind here, and another rectangle. Yeah, here we go. Behind here. Okay, so remember that you might have little computers on this side and little computer on that side, but they will all have some local private IPs, and you might want Paris to know about London, okay, and all the networks here. Why? Because you might want to, let me just take something in here. So let's say you have a server, a host here, and you have another host here. So you have a server here and a server there. Oh, sorry, that's the, okay, let's do this. Bring it down a bit. No, let's minimize that. Okay. Okay, so this might be on the 192.168.10.0 network, subnet mask 255.255.255.0. This might be on the 10.10.20.0.24 subnet mask. The two of them communicate over a different network. So let's say they use the 173.16.51.2 and then slash, and then let's say it's slash 30. So that will be 255.255.252. So we only have two nodes. So we will do a subnetting to know which one goes here and which one goes there. Okay. But for the meantime, so this is where we are right now. So what do we do to get our routing started? So now you have to identify the interfaces. So the interface here is S1 and the interface here is S1. I should have perhaps used X2. Why don't I just get rid of this and use a different interface? So I'll use X1/2 here, and then X1/1 here. Okay, so we can troubleshoot better. Okay. Now, with OSPF, you would say that if we can be in one area, that is, if we can be in one neighborhood, we can talk to each other. So we will stick an area here, and that's the whole area. Okay, so this area will cover London, and let me see if I can lower it one area. Yeah, so there we go. And then yeah, lower one area. Good. Yeah, so we will call this area 0. Area 0. And you know, if you use Windows a lot, you could go to Task Manager. And one thing you will realize is that we have something called, let's check what is over here. This performance, the services are here. Process ID. So the processor ID identifies a process ID, a unique number that is assigned to a particular process. So for example, WSearch, it uses 8172. TeamViewer uses 3700. Volt SVC uses 816. And you get a drift, okay? 3708. Okay. So as I was saying, so you got in the area and you got the process ID. Now, let's use a process ID that's as simple as ABC, and let's make our PID 1. Okay. Now the interfaces taking part in the OSPF area 0 are X12 and S10 for now. Now to be able to discover what is on this side of the LAN over here, okay, what is on this side of the LAN here, sorry, this side, we have to identify the interface going down to this LAN. We'll do that in the next slide, and then we'll do the same for this bit here. Okay, sorry, my machine is too powerful, too quick, sorry. I don't know if it's too powerful, but it's quick. Okay, so why don't we dive into configuring our OSPF? So let's minimize this a bit. And I'm going to start London. And I'm going to go ahead and launch the console. Okay. Okay, hopefully you're able to see a little bit better. Let's change the settings here, see if we can make the font a little bigger. I don't use this very much, so just if you don't know, well, I've never had to change the font anyway, so what does tell us say here? Nothing. Okay, hopefully you see what's happening here. So this is London. First what I'm going to do is I'm going to go to the global config mode, change the host name to London. Okay. Control C, and then over here, let me just see show IP interface brief. Let's see what sort of ports we have on this. So now 012 is this one down here. Okay, it's unassigned at the moment. we might need to give it an IP address. And mind you, we decided to use 173.16.51.2/30. Okay, so let me pause for a moment and get the right IPs going to the left and the right of the nodes, and then we can work together. But to get to 51.2, it's a 30. So let me minimize this and open a notepad. Let's do some subnetting here. So 173.16.51.2/30. So if it's 30, it's 255.255.255.252. Okay, 252 is how many ones? 1, 2, 3, 4, 5, 6, and then 1 and 2, because 255 minus 3 is 252, 0, 0. Okay, so the increment actually is so we have 128, 64, 32, 16, 8, 4, 2, 1. So the increment actually here starts on the 4. Okay, so originally 172.16.51.0 is the first one. 172.16.51.4, because of the increment. 172.16.51.8. Now this one goes to 3. This one goes to 7, and this one goes to 8 plus 4 is 12, so that's going to be 11. So let me just write it down here: 172.16.51.12. Okay, so now we do know that this 2 here is actually in this range here. So here the start IP is actually not the 0, 0 is the network. Start IP is 1. And then last usable IP is 2, and broadcast is 3. So now the IP address 1 and 2 can be used. So brilliant, it works for us. So this is going to be .1, and this is going to be .2. All with the subnet mask 255.255.252 or /30 prefix. So let's go over here and then let's see if it will work. So conf t interface serial 1/2 IP address 173.16. And remember that was the 1. 255.255.255.252. Description if you want, and I'll say one interface to Paris, and then I'll say no shut. That interface opened. Control Z, copy, run to start. Yeah, okay. So show IP interface brief. So this is what we have here at the moment. Okay, it's up. So now I'm going to do the same thing over in France. So I'll go here and I'll go start, and then I'll right click here and I go to console. And whilst I'm here, let's do, I need to be patient. Patience is the key. As a network engineer, you must be very patient. Okay, the interface over here, let's see the interface. It's serial 1, 0. So show IP interface brief. Okay, serial 1, 0 is unassigned. So conf t means let's enter to the global configuration mode. Okay, so now interface serial 1/0. the IP address, remember that the first one was a .1, and this is going to be 173. So IP address is going to be 173.16.51.2. In actual sense, because I made this up, I realized that what I wrote down here is actually not a network. It's actually the the IP of S10. So 255.255.255.252, and I'll put a description here. One interface to London. No shut. Control Z, copy, run to start. Okay. Okay, so now Paris is app with an IP. Show IP interface brief. Okay, so it says app, all right? Okay. Now, because the network is a 0, I'm going to correct this here. So whenever you're given an IP, try and subnet to perform subnetting to find out what it really is. Okay, don't just assume that's a network because it's there. Because I made that up, and then I realized that there's 1 and 2 here. Okay, not the 2 as I originally wrote down. So now I can do show Cdp Neighbors. That's a Cisco proprietary information. It says we are connected to London on the serial 1.0 interface. That's correct here. And then we're able to do routing and switching and other integrated services. The platform is 3745, and it's going to the port number 012. So that's how it tells you. So always remember that the first serial is a local interface. The port ID is the not the local, but your peer interface. Interface, yeah. Okay, so now I'll do ping 173 .16.51.1. Oh, success! Wow! So that's written. The IP address, the right subnet mask has been applied to the interface, and now we're able to ping to each other. So now traditionally, because they are show IP interface brief, and I'll do show IP route. It would show that this is directly connected. So the C, it says I'm connected, so I know this interface. But with Ospf, what you're trying to do is saying, London, if anyone joined this network here, please let me know. So London is going to say, okay, I'm going to stick, if anyone joins this network here, I'm going to make you fully aware. So you can put that in your table. So boys from here can ping to girls from here, and girls from here can ping to boys. Well, that is if they want to do some dating or catching up, but essentially I'm just saying that they can communicate, really. So over here, I'll come down here, and you come down here. Okay, so that's you here, London and Paris. Okay, so now this 2 is done. So which interface is going to take part in the Ospf area interface? Is going to be serial 1, 1, 2, and then serial 1, 0. So we go down here. So from Paris, let me just go from London actually. Let's do 1 by 1, and let's go to console. Okay. Okay, so now on London, we're going to configure the Ospf. Remember that the network we'll be thinking about is this network here. Both sides, we're going to do that. So we're going to go ahead here and go to conft. Now we type words like router, Ospf 1, area 1, and then the network is where you're saying this is part of that Ospf network. So it's going to be 173.16.51, and remember this is .1. Okay, now the wildcard here, and let me explain how that works. So the wildcard is always going to be 255 minus the subnet mask of network. So 255 minus 255.255.255.252. Hang on, don't worry, I know I missed a bit here over here. Okay, so you go here now, so that's going to be equals to 0.0.0.3, but the 3 is for the full network, but we don't want to do it that way. We want to do it as specific for that interface. It's going to be 0.0.0.0. Okay, because if you're sending a broadcast, it would have been 255.255.255.255 or ff.ff.ff.ff. But so we're going to just say specifically here. So I'm going to say 0.0.0.0. Which area? Area 0. So that is my side here. And I'm just being specific on this interface here. And so this is taking part in the interface. So now, is there anything here I need to do? We've done the area already. Yeah, passive interface. So I'll say passive interface. Default. I'll say no passive interface. I want this to be part of the area of the Ospf. So there's no passive interface, and it's going to be serial 1/2. This only says that don't make this interface passive. Make it part of the Ospf process. If you have an interface, you don't want it to be automatically involved in the Ospf routing protocol process, then you say passive interface. So you can actually say passive interface S12, and then you can do passive interface default. So that you can connect to any network here, and then it will take part in Ospf, but just the specific ones. Okay, it saves you a lot of time and performance on your machine. Okay. So now this is done here. So we're gonna go to Parry and go to our console. Come over here and we go to the global area, global config mode, conf t. So router, Ospf, process ID 1, network is 173.16.51, and then we're going to do .2, 0.0.0.0, and area 0, and then okay, copy router Ospf 1, and over here I'm going to say no passive interface 0.1.0, and then right, we can do that, but normally just do copy, run, and start. Okay, so now our Ospf it's enabled, so show IP route, show IP protocols. So it says at the moment that I'm running Ospf. This interface here, the 2 is in that area. Okay, so now the interesting thing is Paris knows about London. Okay, and so I'm going to go and attach something to London, but I'll stick it in a different interface, a different IP. So go over here and tell you what, let's take another router here. Another router here. Okay, take that out for a moment. Okay, another router here. I'm going to turn the router into a computer in a moment. Okay. Remember, I'm going to use that as an opportunity. Change the symbol. I'm going to turn that into a computer now. Okay, and this is going to be here. Yeah, okay. Okay, so we have a router here. Okay, and it's going to be in this network. Okay, so fast Ethernet 01 knows about this network here, but Paris doesn't know that yet. So OSPF is going to show Paris that, hey, London has a private or LAN here with this particular IP range, and you can get to know it, put in your routing table for future use. So let's go to London now, but before that, let's just run this one here, and let's go to console and turn this into a computer. Okay, so in Cisco's, what you would do is okay, so you say no IP routing for Cisco's, and then you set the default gateway. So do WR say the default gateway will be the IP address of the router that is over here. So the Ethernet's F01 interface IP is going to be the IP default gateway. So now here we go. So IP default gateway is going to be, and I've not said that yet, but I'm just say 192.168.10.1 255.255.255. Oh no. You see, you can forget these things easily, but there's nothing there. So just do and WR or save. Okay, remember this has got an interface. So just as in Windows, you could go to your adapter card, and for example, like on my Wi-Fi, I could just go down here and go and specify an IP address. Okay, although now it shows here with this IP address, I could also do the same here. So it's a PC1. So let me just go to conf host name. Sorry, check your spelling all the time. Host name is London PC1, and then DWR. Okay, because I said DWR because I want to stay in the interface and do something. So, and this is quite slow. Okay, so interface first IP address 190.168.10. Let's say 15. 255.255.255.0. No shot. Copy, run to start. Okay. So now if I did ping 192.168.10.1, which is the IP address of the fast Ethernet 01, you're going to get no response because there is no IP configured on that yet. So let me just take the details in here. So .1 and then .15. Okay, so there's going to be 15. There's a 10 network here. London PC 1. Okay. Let's bring it down. Let's so it becomes a little tidy. I think it's because it's turned on. So, okay. So ignore the for now, but that's London PC1. Okay, and there's the interface. So that's on 15, and there's a 1. So now I'll go to London here, and I will tell London conf t interface fast node 01. No. Yes, IP address, of course, 192.168.10.1 255.255.255.0. no shot, control copy, WR, that's copying. And now I will go to, which is London PC1. Remember the ping wasn't correct before. Now let's see. That's what happens with the ping. So here we go. Ping is working fine because now London is able to speak to the router. Now let me go to Paris right now. Okay, let's go to Paris and let's say if Paris can ping London. So ping any IP in London. So I'll say London PC1 192.168.10.15, and we don't have to get any response because it doesn't know. But what OSPF is able to do, and that is amazing, is this. OSPF is able to tell Paris right now that, hey, I've got this guy who's just joined my network, and he is a good guy. I want you to keep his details here and make him a friend so that your people here can talk to them and chat and gossip and whatever. So let me try and still stop this and give it a good name. London PC1. Hopefully it works this time. It has worked. Praise God for that. Okay, and then let's start it again. So now I'll go to London and I go to console and conft. What am I doing? I want to go to router, OSPF1, and I'll say network. This time involve this IP here. Network, always do that. 192.168.10.1, and I just want you to advertise here. So I can do the whole of that network, but do I need that? No, I just want you to be specific on here. 0.0.0.0 area 0. No passive. Fast 0 is the one, and then WR. Okay, so that is done. Let's see if London here is started. Let's go down here and console. London is still down. What happened? Uh-oh. London is still down. What did I do wrong here? Hang on, guys. Let me just